Picking up where we left off, we were looking at explosions. Remember, an explosion is when two particles that are initially touching push apart and move away from each other. Okay, so an explosion could be something like a bullet leaving a gun, or a cannonball leaving a cannon, or an arrow leaving the bow, or it could be two people pushing against each other, or it could be the parts of a bomb moving apart. So we're going to look at problems 26 and 28, and then we're going to look at some 2D problems. So let's go to 26 and 28. Okay, let me adjust the book here. There they are, problem 26 and 28. Now, problem 26 says a 50-kilogram archer standing on frictionless ice shoots a 100-gram arrow at a speed of 100 meters per second. What is the recoil speed of the archer? Okay, now if we look at the before, we have the archer here with the bow, with the arrow. And they're standing on ice, okay? So I know the velocity initially of the archer is 0. Velocity initially of the arrow is 0. So momentum initially is 0. Well, the sum of the momentum initially is 0. After, okay, the person with the bow should be going in this direction, V final archer, and the arrow is going in this direction, and its V final is given to us as 100 meters per second. Okay, we're also told that the mass of the person, the archer, is 50 kilograms. Mass of the arrow is given to us as 100 grams. So that's 0.100 kilograms. Okay? So what I can say is sum of the momentum initially has to equal sum of the momentum final. So I have 0 is equal to 50 kilograms times velocity final of the archer plus 0.100 kilograms times 100 meters per second. So if we solve for V final of the archer, it's going to be 0.1 times 100 divided by 50, and when I took that over it was negative, I get minus 0.200 meters per second. Okay? If the arrow moved out in the positive direction, the archer had to move in the negative direction. Not a bad problem. Okay? Now, if we go and we read problem 28, it says Dan is gliding on his skateboard at 4 meters per second. He suddenly jumps backward off the skateboard. Okay? And the skateboard, kicking the skateboard, and the skateboard's forward speed is 8 meters per second. How fast is Dan going after his feet hit the ground? Dan's mass is 50 kilograms. The skateboard's mass is 5. Again, we think about before and after. Okay? The mass of Dan is 50 kilograms. The mass of the board is 5 kilograms. Now, I kind of got some pre-stuff written here on the board. Okay, so before, we have our person standing on the skateboard. Okay, and they are traveling in this direction, V initial. They're one object, and they're traveling at 4 meters per second. So momentum initially would be 55 kilograms, their combined mass, times 4 meters per second. So if we pop that through, 55 times 4, that's 220 kilograms meters over seconds. Now after, okay, I know that they have separated, and the velocity of the skateboard is given to us as 8 meters per second. I am betting that our person here is going to have a V final in the forward direction, but I could be wrong. If I'm wrong, the number for V final, the velocity, will be negative. If I'm right, it'll be positive. So sum of the momentum's final is going to be 50 kilograms times V final plus 5 kilograms times 8 meters per second positive. So I have 220 kilograms meters over seconds is equal to 50 kilograms V final plus 8 times 5. I don't know why I'm punching that in my calculator, which is 40 kilograms meters over seconds. So I subtract, I get 180 kilograms meters over seconds equals 50 kilograms times V final. So I get V final to be 3.60 meters per second, and it's positive. So it means that after the explosion, okay, they pushed against each other and separated, that the person is now going 3.6 meters per second in the same direction as the board. All right. I wanted to do this one because in this one, the two things that are pushing off from each other are moving to begin with. All right, so that's our example of some explosions. Okay? Now we're going to look at a 2D problem. Up to this point, we've just been looking at collisions and explosions in one-dimensional cases. Now we're going to move on to two-dimensional case. Okay, in two-dimensional problems, we got to remember that momentum is a vector. And because it's a vector, we're going to need to look at the sum of the momentum in the x direction, the sum of the momentum in the y direction separately. Okay, so all this is going to require is for us to take our motion and think about dividing it up like we have in every other case that we've looked at, where we've had 2D motion. We've got to look at the x motion and the y motion separately. Okay? So we're going to look at problems 33 and 32. So let's get back to the problems. Okay, we're going to look at 33 first, and then we're going to look at 32. In problem 33, it says a ball of clay traveling east at 3 meters per second collides with a 30-gram ball of clay traveling north at 2 meters per second. What is the speed and the direction of the resulting 50-gram ball of clay? Now notice this is an inelastic collision because the balls stick together after the collision. So in our before, we have ball 1 traveling east at, let's see, ball 1 is traveling east at 3 meters per second. So this is our 20-gram ball, and it's traveling east at 3 meters per second. If I assume that this is my plus x, that's going to be my plus y direction. East would be plus x. Okay, and our second ball is traveling due north. The velocity is 2 meters per second, and this is a 30-gram ball. After, okay, I've got one 50-gram blob, and it's going to be traveling at some direction like this, V final, at some angle theta. Okay? Now, if I think about momentum initially in the x direction, well, my 20-gram ball is traveling at plus 3 meters per second, and my 30-gram ball is only traveling in the y direction, so I'm going to have 30 grams times 0. Sum of the momentums initially in the y direction is just going to be 20 grams times 0 plus 30 grams times a plus 2 meters per second. Okay? Now, that has to equal the sum of the momentums final, which in this case would be 50 grams V final X and 50 grams V final Y. So if we do this, 20 times 3, so I have 60 grams meters over seconds equals 50 grams V final X. So 60 divided by 50, V final X is 1.20 meters per second. Since everything was in grams, notice I used all my masses in grams because they're going to divide out. If we had a mismatch of mass units, we'd have to make them match. And if I want to know the momentum in correct SI units, I would have to use my mass in kilograms. But since I'm looking at the before and after, I don't have to use it in kilograms. If I look at the sum in the y direction, I would get 60 kilograms meters over seconds because 30 times 2, grams, is equal to 50 grams V final Y. And look, V final Y is also 1.20 meters per second. Okay? So if I want to get V final, it's the square root of 1.2 squared plus 1.2 squared. So I get 1.70 meters per second, and our angle theta is the inverse tangent of 1.2 over 1.2. Yep, 45 degrees. So this angle is 45 degrees, and this velocity is 1.70 meters per second. Okay, now let's look at problem 32. Now here we're given a pictorial representation. It says an object at rest explodes into 3 fragments. Figure 11.32 shows the momentum vectors of 2 of the fragments. What is the momentum of the 3rd fragment? Write your answer in unit vectors. So in other words, I want an x component and a y component. Now, if you look at that guy, then if I look at part 1, if I think about part 1, looking at this graph, I can see that it's got a -2 momentum in the x direction and a +2 momentum in the y direction. So P1x is -2 kilograms meters over seconds. P1y is a +2 kilograms meters over seconds. And these are the finals. Okay? Part 2 has a momentum final in the x direction of +2 meters per second, and a momentum final in the y direction of 0. Okay? And we know that the sum of the momentums initially has to be 0. So I want to get momentum 3x final and momentum 3y final. Okay, so sum of the momentums in the x direction, which is -2 kilograms meters over seconds, plus a +2 kilograms meters over seconds, plus the momentum 3x final, all have to add up to be 0. So momentum 3x final has to be 0. Okay? Sum of the momentum in the y direction would be a +2 kilograms meters over seconds, plus 0, plus momentum 3y final, and that all has to add up to the 0. So I know momentum 3y final has to be a -2 kilograms meters over seconds. So in component vectors, the x component is 0, the y component is -2 kilograms meters per second. So you could say momentum 3 is 0I plus a -2J kilograms meters over seconds, if you wanted to write it in IJ component form. Oh, correction, I made a mistake. Do you guys see the mistake I made? Teaches me not to look at the work I've already done. I made a mistake. This one's not a 2, this is a 3. So let's go back and fix it. Whoops. Sorry, you guys just fell. This should be 3. That means this is 3. That means this has to be a -1 kilogram meter over seconds. Okay? Doesn't change this. So my momentum vector in ij form would be a -1I plus a -2j kilograms meters over seconds. So the x is -1 kilograms meters over seconds, and the y is -2 kilograms meters over seconds. And that looks much better. Okay? Now, the last thing that we need to talk about in this chapter is the difference between an inelastic and an elastic collision. Let's get back in place here. Okay. In an inelastic collision, the objects stick together after collision. Momentum is conserved, and if we look at the moment right before collision and right after collision. In an elastic collision, the objects bounce off each other after collision. We see conversion of momentum, and we also see conversion of mechanical energy. Okay? We'll talk more about that later. It's very important when we start talking thermodynamics. For an elastic collision in one dimension, where we have 2 balls, okay? And ball 2 is at rest before the collision. So its momentum initially is 0. We get the following. V final x for object 1, the ball that was originally moving, is equal to m1 minus m2 over m1 plus m2, Vx initial for object 1. The velocity final in the x direction for object 2 is equal to 2m1 over m1 plus m2, V initial in the x direction for object 1. Okay? And these are plug and chug equations. I've included problem 22 in the packet that I've given to you for you to look at. Okay? I don't think I need to do it because it's a plug and chug problem. Now, the rest of these problems here are some random problems that I would like you guys to try to work. Okay? And I will give you solutions for these. Guys, this ends the material for test 3. Okay? So you've got chapters 9, you've got 11, 10, 9, and chapter 8. So that's 4 chapters for this test. But I think you're going to find this test a little easier than the last one. All right.